Continuing once again in the First Global Revolution, we are in Chapter 9. This is Part 3. The title of the chapter is Agents of the Resolutique, and we are in a section that is subtitled To the Contribution of Science and Technology. In the industrialized countries of the North, society has been shaped by technology. The way of life has adapted to make full use of it, and prosperity has been built on it. Technology imported from the industrialized world has also penetrated into the urbanized areas of the South. At the same time, many of the problems of contemporary society have been caused directly or indirectly by technology, or more often by its misuse. It is to be expected, therefore, that technology with its seminal partner science will be an essential element of the Resolutique. Science and technology are too often loosely assumed to be more or less two aspects of the same thing. Research and development gives rise to science and technology. In reality, the system of science and that of technology are very different. That of science is open, and its product is freely disseminated through the world. That of technology is directed by economic motivations, and its products are jealously guarded commercial property. The role of science is to uncover knowledge. Its process explores the unknown and provides new data. Data is not itself information, but the raw material of information. Through selection with a sense of relevance, human intelligence orders and coalesces data to produce information. A matrix of information can become knowledge. Again, knowledge does not spontaneously generate understanding. This requires, for its arising, wisdom born of experience. Thus, we are concerned with a continuum which runs from crude data through information and knowledge to the end refinement of wisdom. Data we possess in large quantities, and information can easily be concealed and lost in its disorder. Today we have enormously greater amounts of information and knowledge about man and the universe than our forefathers had, but there are few signs that human wisdom has increased significantly over the last 5,000 years. In these difficult and complex times, we begin to realize that the pursuit of wisdom is the essential challenge that faces humanity. And we have another one of these insert boxes, and it says, where is the knowledge which is lost in information? And where is the wisdom that is lost in knowledge? And that was said by T.S. Eliot. One would expect, therefore, that research on the nature of wisdom and its generation would be a number one priority. But have we the ingredients to start such a project? And if presented to one of the great foundations, would it have a hope of acceptance? However, in recent years, much knowledge has been gained on the workings of the brain, on brain and human behavior, and indeed on the nature of Homo sapiens. Such interdisciplinary research, which involves biochemistry, physiology, neurology, endocrinology, molecular biology, psychology, anthropology, and many other sciences, holds great promise and should be actively supported. Through its findings may seem at this stage merely theoretical. It should explore not only the rational mind, but also emotional and intuitional aspects of being, which play such an important part in the life of the individual and his often apparently irrational attitudes and behavior. Research aimed at the extension of knowledge without any aim of immediate practical use is known as pure or fundamental research, and its scientific product is an element in the mosaic of ever-growing knowledge. It is usually undertaken in the university laboratories or, as in the Eastern European countries, in the institutes of academies of science. Scientific understanding arising from pure research is an essential element of contemporary culture. University research also has an important educational function. University teachers who are actively engaged in research and hence working at the advancing frontiers of knowledge are able to transmit the spirit of the scientific method and to inspire their students. This function is as important in the less developed as in the industrialized countries. Indeed, it is a prerequisite to the understanding of today's world, necessary if the offerings of science and technology are to be usefully included in the process of development. There is a second type of fundamental research increasingly pursued in the industrialized regions, namely oriented fundamental research, which is an essential feature of input in the development of the most advanced technologies. Such research, while not expected to have direct practical application, is needed to illuminate areas of ignorance which have to be overcome in the development of advanced technical processes. Such research may be carried out in the laboratories of corporations or under contract by universities. It can thus be a very useful link between industry and academia. Much research today is of a directly applied nature, aimed at resolving specific problems in industry, agriculture, or the public services. It may by nature be research in the natural sciences such as chemistry, physics, and biology, or in economics and the behavioral sciences. Indeed, the complexity of so many of the contemporary problems demands a combined attack from several disciplines. Experience shows that in such multidisciplinary approaches, research workers from many sciences, natural and social, in dealing with a particular complex problem, soon acquire a degree of communication which transcends the boundaries between the disciplines. The cultivation of multidisciplinary research is urgently required by the Resolute. It is difficult to generate within the universities, which are vertically organized into departments and faculties, often with little contact. Applied research, of course, needs to be greatly extended in the developing countries where it already widely, if insufficiently, pursued in the agricultural sector. In such countries, it is much less common in industry, since the small size and relatively low level of sophistication of firms makes it difficult to identify technical problems or to afford to employ scientists to solve them. Technological development is the essential but only the initial step in individual innovation. It consists in bringing together technical knowledge acquired through research or by purchase and to evolve it through the chemical pilot plant or engineering prototype so as to be a reliable and effective manufacturing process competitive on the market. The cost of the development phase is usually an order of magnitude more expensive than the research stage on which it is based. But there are many other elements in technological innovation, such as market surveys to test out the potential demand for the new product and hence its economic viability, the acquisition of risk capital and of management skills, as well as recruitment and training of a reliable workforce. The cost and complexity of industrial innovation has meant that much of the industrialization in developing countries has been done by the multinationals or by the import of turnkey technologies from abroad. And we will end this portion of Chapter 9. This is Part 3. We will pick up with Part 4 in the next video.